This is about the problems in electromagnetic induction and alternating current. An aircraft having a wingspan of 20.48 meter flies due north at a speed of 40 meter per second. If the vertical components of the Earth's magnetic field at the place is 2 into 10 power minus 5 Tesla, we need to calculate the EMF induced between the ends of the wings. That's the answer. That's the question. So the length L is equal to 20.48, V is equal to 40 per meter per second, and B is equal to 2 into 10 power minus 5 Tesla. As you know, the EMF is induced by changing the area enclosed by the coil. So we got as E is equal to minus B into L into V. Substituting the value of B, L and V, you got this one. Solving it, you got minus 1638.4 into 10 power minus 5, which is nothing but E is equal to minus 0.0164 volts. So now let's look into the other problem. Calculate the mutual inductance between two coils when a current of 4 ampere changing to 8 ampere in 0.5 seconds in one coil induces an EMF of 50 millivolts in the other coil. So I1 is equal to 4 ampere, I2 is equal to 8 ampere, dt equal to 0.5 seconds, E is equal to 50 millivolt. So that's 50 into 10 power minus 3 volt. What is the value of mutual inductance M? Here is the solution. E is equal to minus M into di divided by dt. So in the case M is equal to minus of E divided by EI divided by dt, which is equal to minus of E divided by I2 minus I1 divided by dt. Substitute in the value of equation of this one, you got it right. E as 50 into 10 power minus 3 divided by 8 minus 4 divided by 0.5. You got 4 divided by 0.5, that's 50 divided into 10 power minus 3 divided by 8, which is nothing but M is equal to minus 6.25 into 10 power minus 3, that's nothing but M is equal to 6.25 millihenry. So the mutual inductance between two coils is 6.25 millihenry. Now let's move on to the next one. A bulb connected to 50 volts and DC consumes 20 watt power. Then the bulb is connected to a capacitor in an AC power supply of 250 volts, 50 Hertz. Find the value of the capacitor required so that the bulb draws the same amount of current. This is the question. So P is equal to 20 watts, V is equal to 50 volts, nu is equal to 50 Hertz, and we need to find the capacitor C. So power is equal to V into I. So I is equal to P divided by P, V. So 20 divided by 50, that's 0.4 ampere. And if you talk about the resistance, R is equal to V divided by I. So R is equal to 50 divided by 0.4, that's 125 ohms. Whereas the impedance Z is equal to V divided by I, which is nothing but you got voltage as 250 here. Divided by 0.4, we got 625 ohms. That's the impedance. So as you know, P, V, nu is Z, R. We identify everything, we need to identify C. So we know the equation Z is equal to R square plus 1 by omega C whole square on the whole root. So this is the equation. But omega can be rewritten as 2 pi nu, since nu is known. So squaring this one, you got Z square is equal to The root is removed. R square plus 1 by 4 pi square nu square c square. So obviously you are able to get C is equal to Z square minus R square root 2 pi nu. So this is the equation. So substitute the values for nu as 50, Z as 625 and R as 125. You got this one. So 625 is 390625. 15625 is 125 square. You got 2 pi into 50 into root of 375000. So root of this one is 612.37. So solving this one, you got C is equal to 1 divided by 1922. The answer is 5.198. That's the answer. So we got the answer as the capacitance required is 5.198 microfarad. Now let's move on to another problem, that's AC generator problem. An AC generator consists of a coil of 10,000 turns and of area 100 centimeters square. The coil rotates at an angular speed of 140 revolution per minute. It can be given as rotate per minute too. In a uniform magnetic field of 3.6 into 10 power minus 2 Tesla, find the maximum value of the EMF induced. That's the question. So N is equal to 10,000. Area is equal to 10 power 2 centimeter square, 10 power minus 2 meter square. B can be given as 3.6 into 10 power minus 2 Tesla. We need to identify E naught. Nu is equal to 120 rotation or revolution per minute of 140 divided by 60 rotation per second. Let's move on to the solution. The peak value of the EMF E naught is equal to N A B omega. So omega can be rewritten as a 2 pi nu. So N as 10 power 4, A as 10 power minus 2 into B as 3.6 into 10 power minus 2 into 2 pi nu, that's 140 divided by 60. Solving this equation, you'll be getting as 3.6 into pi into 140 divided by 30. Pi can be tallied as 3.14. You got the answer as 52.756. So E naught is equal to 52.756 voltage. That's the answer. That's the EMF induced. So the maximum value of the EMF induced is 52.756 volt. That's it. Thanks for watching our GTech Techno Solutions product on physics problems. Thank you.